My name is Mutlu Ahmetoğlu, and this is my performance video for EE361 Lab Experiment 1. Let's start with the first question. The question asks whether the fill factor can exceed 100%, whether it can be 144%. And of course, the answer is that it's not feasible, because you cannot fill something beyond itself. The extent to filling something is 100%. After that, it's full. That's why it's not feasible to have this fill factor in physical construction of the circuit. Now, the second question asks why the calculated L value, the inductance value, is different with the measured L value with the LCR meter. The answer for this question is that when we make the calculations, we make a lot of assumptions and roundups. For example, we take the relative permeability of the magnetic core to be 200, 2000 exactly, which is not. We take a length value, which is not exactly the real value, area value, exactly the same thing, and even with these values, we find the turn number value to be 14.7, which is of course not feasible physically. So we took it to be 50. But the fact is that when we make the calculation, we take the square of the turn number. So there's a discrepancy there. All these can affect the measurement and the calculation. There should always be a discrepancy. And for the third question, it asks why the measured L value is different for two same cores. The answer for this is kind of similar with the second question, because they're not exactly the same. Even the winding of the core are not exactly the same, which can cause a difference in the flux linkage. Also, there are experimental errors, there are different electrical components around, like phones, which can affect the measurements. Also, the device is not a magical box that gives you the exact value. You can see it when you measure it. It always changes, the value always changes. So that's why there can be small discrepancies between the values. Other than that, on paper, those two cores are exactly the same. They have the same turn number, they have the same core, the same material used in the cores and the cables. So the only difference is with the experimental physical differences in the medium. Now let's come to the last and fourth question. It says why there is a big significant difference in the inductance values when the second inductor is reversed in series connection. And this is an interesting thing, because the inductor in lump circuits is a symmetric component. Even if it doesn't have a magnetic energy stored beforehand, which is not the case here, we're not discussing that. And if that's not assumed, then it's a symmetric component. It shouldn't change the direction. The direction shouldn't change the result, but it changes it anyway. Why? The reason for that is that these inductors are wound to the same core, and the core is a ferromagnetic core. It has a high permeability value. So these inductors are highly coupled. There's a mutual inductance between them, and when you connect them in reverse direction, then the mutual inductance changes sign. It becomes negative. Instead of contributing to the equivalent inductance, it lowers its value significantly. This is the reason why there's a big difference between the equivalent inductance values in the forward connection and the reverse connection. So these are my answers for the questions. Thank you.